All right, what's up, everybody? We just tried doing the last hangout on DNA and water with Phoneybeetlemaniacxs, and we had some technical issues. Um, I guess we're going to leave it off where we left off. We're going to continue on dissolving and degrading, if they basically mean the same thing. I did send the link again to Phone Beetlemaniacxs. Hopefully, he's able to come in right now. I also sent him the invite. But yeah, there's been a lot of misunderstandings over this DNA and water situation. And with all due respect, a lot of the people in our community have been displaying a heck of a lot of ignorance over this particular topic. Those that do know about it, like Fiona, are avoiding debate over this particular issue because they know that they can nitpick on minor issues and points or semantics rather than any actual science. But they don't want to appear to be wrong. So that's the purpose for this particular discussion, to help to try to sort out some of these misunderstandings. The intention is not really to try to talk about drama, but just so that people understand better the impacts that this topic has on abiogenesis, because the impact that water has on not only DNA, more so RNA and the first self-replicators that possibly came before RNA, because they're more fragile than DNA actually is. Nobody really thinks that DNA was the first self-replicator. It has a very serious impact on DNA and water because if you're dealing with the environment, some sort of ocean foam or free-floating nucleotides in the ocean, or any of these other ideas in abiogenesis, what are you going to do with that when you relate it to the temperature of the environment at that time? Like a lot of people believe with the greenhouse gases before they came into circulation from about 200 degrees Fahrenheit to 2000 degrees Fahrenheit, it's going to break apart rapidly in water. So hopefully Phoney can come in here pretty soon so we can start to talk about this. Let me go back to my G Plus and okay, Phoney's saying that he's having some trouble with the link. I'm going to try to, I think I added you on one of your accounts already in the Hangout, Phoney. Phoney. Phoneybeetlemania. I send it there. Try your other account. Try to come in on your other account if you can.
Okay, so yeah.
All right.
I don't know what was wrong with my lookout. I don't know. It's a block thing or something like that.
Yeah, everybody's been having trouble with that, man. I don't know what it is, but for some reason, whenever you send the link, people have trouble coming in. They seem to be able to come in better when you invite them. So you're saying that you were disagreeing that dissolving is synonymous with degrade, right? That's where we left off, right?
Yeah.
Now, I'm going to point out the fact that this is actually a misunderstanding. I'm going to screen share something.
Okay.
Okay, so can you see what I'm screen sharing?
Yeah, the solubility review from Tufts University. Yes, you showed me that before.
Yeah. Okay. So it says this molecule, it says, are also polar because of the negativity charge phosphate group, the PO3. They're talking about the partial negative charge on the sugar phosphate backbone. Along the sugar phosphate backbone, they just said that because of this, DNA and RNA can easily dissolve in water. What do you think that dissolve means?
It means it's become totally liquid in water. That's what dissolve usually means, doesn't it?
Okay, well, here's the definition of dissolve. Dissolve, with reference to a solid, becomes or causes to become incorporated into a liquid so as to form in a solution. Well, what is synonymous with this? Breakdown, right?
Yeah.
Okay, synonymous.
Okay.
Now, what does degrade mean? To break down or to deteriorate chemically, right?
Yep.
Okay, so if A is the same as B and B is the same as C, is C the same as A?
No.
Okay, now how is that possible?
Because breakdown in the way that solubility means, it means absorb into. Degrade in the way that we're talking about doesn't mean that. What it means is that it means that the chemical composition of the item has changed.
Okay.
That's what we mean by degrade. So let's say, for example, have you when you were at school, did you ever put anything in acid?
So you got to repeat that, man. You broke up for me.
Sorry. I'll try and repeat. Sorry. My mic has a habit of looking in. I don't want it because it's put me on goddamn my logic camera instead of my. Oh, here we go. Just change my camera. Yep. Is that better? Because I've changed it to my my USB one now.
No, that's better. I think it's just that I had you your volume down a little bit. So can you repeat yourself, please?
Okay. What I said was that the degrading in the method you talk about, degrading means is that the chemical composition has been overtaken. Now, the question I asked was, when you were in science class at school, did you ever dissolve anything in acid? Did you ever degrade anything in acid?
Degrade anything in acid? What do you mean by
like for example, I mean, I remember, like, I don't know.
I've used things in a solution, but when you're using something in a solution, you need a base and an acid. So the acid, usually the acids are something that's soluble that you put into the solution.
Yeah. Well, no, because when I talk about acid,
it can be ammonia, so it can.
It's like chloric acid or something like that. Because, like for example, what we used to do at school is like see the different dissolving or degrading aspects of items when we put them in different solutions. Like, for example, I remember one where we put it in like a certain type of acid that we couldn't really handle with hands, and we had to like put them out. I think is that now the thing is, it would take a while to dissolve. It would take ages to degrade. Like, for example, if we could find like metal composites by doing certain tests on it. Now, that's the difference between dissolve degrade. It would dissolve pretty easily. It would take ages to degrade. It would take maybe about a minute, 2 minutes to dissolve. It would take about.
The problem is it would
take about 5-10 minutes to degrade.
Okay,
because the chemical composition had to change.
Time is irrelevant to the fact of whether or not something is going to break down. It could take a long time or a small amount of time for something to break down. The point is that if dissolve it means breaking down, and degrade means for something to break down or deteriorate chemically. There's no way around it. That's what it means. Here's a website that's dealing with chemistry. chemistry.com, and it says that right over here, dissolving means that a solute breaks up into the solvent, and the covalent solid glucose breaks up, and the molecules enter the water to make the solution. This is basically all that we're talking about. It's for anybody to disagree with what I'm saying right now, you're disagreeing with chemistry in general. That's the point here. When something goes into solution, hold on, Gary. When something is I mean, I just pointed it out to you right now, and I showed you several different sources through Google and a chemistry website over this particular area as well. When something is going into a solution, there's something that's happening on a chemical level. You don't just get to say that, well, it goes into a solution. For example, with sodium chloride, the water molecules will attach to the sodium chloride and pull it apart. With covalent compounds and different covalent compounds, they interact actually differently. Some of them act very similar to even ionic compounds, but with most covalent compounds, they'll break apart the individual clusters that make up the molecule. Or with DNA, I'm suspecting is going to possibly split right down the middle. Even if we're going to disagree with that, I think that that's something that's up for debate that we can talk about. The fact of the matter still is that when something enters into a solution, it is breaking up or coming apart chemically. When something is degrading, it is meaning the same thing. Now, when you're disagreeing with this, I know you keep on saying no because there's a reaction because you've been conditioned to think otherwise. Hold on. But you've been conditioned to believe otherwise because of people in our community. But the problem is they don't know what they're talking about. So if you're going to disagree with what I'm saying here, I would like for you to show some other possible sources to hopefully defend what you're going to say. Because if it's just coming from you, I don't know if we can actually take that for granted. Because to me, if it's coming from you, it's only coming from the people in our community and not from any scientific source.
Okay, because I was looking at DNA storage and quantity from the Oxford Gene Technological Company. The molecular genetics company. It talks about DNA storage and quantity. It talks about reliable measurement of DNA concentration, purity, and how they store it. Like, for example, they talk about that they can store it in liquid form, they can store it in actual steady form. Numerous things. It talks about the lower temperatures. That's one thing I was going to put out there. The thing is, it doesn't go into dissolve.
That's because it's talking about something slightly different. You know what it's referring to, right?
It's talking about how they preserve it in laboratories. Okay,
it doesn't matter. It doesn't matter what we were observing. What do you? All right. Before I say that, what are you trying to say we're observing in laboratories with that experiment?
It's not an experiment. It's how they store DNA in water. And if water degraded DNA, why would they store it in water?
Well, when they store it in water, they have to store it at a certain temperature. And most of the time when they're storing it in water, they have ethanols or other types of elements in there to help keep it in play as well. But what also we have to take into consideration is what type of molecule is DNA.
What kind of molecule is DNA? It's an RNA molecule, isn't it?
How do you determine the pH, for example, in DNA?
It's talking about numerous ways that they do it. Again, what I'll do is I'll post this article for you. You can read it yourself.
I'm trying to help you understand what's going on here, though. That's why I'm talking about this. What does the pH mean? When somebody's talking about the pH, what do they mean by that?
The acidity level. That's what I understand by the pH level.
The hydrogen ions or the hydrogen in the water, basically. That's what they're talking about, right?
Okay, there you go.
The pH, you know what the hydrogen, the pH is referring to, right? I'm asking you some questions here.
Yes, I think so. Again, the thing is that
what is it referring to? Because this is important. We can't really just jump over this point. And I'm not trying
the chemical composition of the liquid that is going into.
It's that's not telling me.
So the amount of degradation that can appear in liquid.
But what is that telling me, though? What are you trying to say by the chemical composition of what? Because DNA is made out of pyrimidine rings and so on. I mean, specifically, what is it referring to?
If you mean the pH level of the liquid it's being put to, it's the acidity level and the degradation level that it would be put through. It must be a preserved agent for DNA to be put into it.
Okay. The pH level, that stands for the power of the hydrogen.
Yes, right? I know what it means.
Okay, so it's supposed to be equal to what?
I don't know, because again, I'm not a scientist. I don't claim to know. I'm saying that I've read
this is important. This is important. It's equal. This is important if you're going to talk about this topic, because if the power of hydrogen is supposed to be equal to the negative log of the hydrogen ion concentration, right? So if you're looking at the pH level of DNA, which is What's important on that sugar phosphate backbone, which makes it water soluble, what is the significance of that?
What is already no mind. But the point I'm trying to get across is that DNA does not degrade in water for at least 100 years.
I know you keep going back to that. You keep going back to that because the people in our community say that, but the people in our community don't understand this. But I'm trying to help you understand the problem what you're saying right now. So if you have a neutral pH is above basically the base, and below that you're going to have basically an acid. So it's the pH level on the sugar phosphate backbone is what makes it basically an acid. It's basically below below a certain level, so it's basically it makes it an acid. But more specifically, if you look at the Ka value that's favoring the reactant, this is making it actually a weak acid. DNA is actually a weak acid. So what is the difference between weak acids and water than other acids when you put it in water?
Okay, so I've just looked up now the pH level of water, and it says 7. It says the pH level of in
that's not what I asked you.
Water. You asked me what pH level is.
Water,
and I've just told you what it
DNA.
says.
What is the? See, you're making a lot of mistakes here. You're making a lot of mistakes here. Water acts as both a base and an acid. That's why it's used by almost every single scientist, as far as I'm aware of. I mean, everybody uses it in their aqueous solutions, except for other liquids like maybe ammonia or something. It acts as both a base and an acid. That's not what I'm asking you. I was asking you about the DNA.
You can't have a pH value
sugar
for an acid.
That's why I'm not asking you at all about DNA, about water, okay? Water is acting as both an acid and a base, right?
No.
Yes.
It's an alkaline.
What are you talking about? You don't know that water can act as both a water and an acid and a base?
It can have corrosive effects, but it takes a long time for it to have those convulsive effects.
Okay, what are you trying to get on about? You need to be a little bit more specific here because you're not making any sense, man.
Right. Okay. The pH. Do you know what the pH scale is?
I know what the pH scale is, but apparently,
where does water fall in that pH scale?
The water acts as both a water and a base for specific reasons, but we're not talking about water right now. We're talking about DNA and water, the sugar phosphate backbone, which is making it an acid, right? The reason why it's making it an acid is it's below the 7 pH scale. At 7, anything below that 7 on that scale is going to determine whether it's going to become a base or an acid.
No. Because 0 to 5 is the acidity level. 8 to 14 is alkaline level. It's a neutral level. Water is neutral. That's the reason that it can be a preserving agent and an acidity agent.
Okay, so you're missing the point entirely. You're completely missing the point entirely. We're talking about the Ka value favoring the reactant, making it a weak acid. Weak acids dissipate into the water differently than normal acids, and DNA is a weak acid.
What DNA isn't an acid?
I'm sorry. Well, what'd you say?
DNA isn't an acid.
DNA is an acid. DNA is a weak acid. You see, this is the point that I'm talking about. You're displaying a lot of very strange statements right now. It's displaying your ignorance. And when we're talking about the pH value, that specifically only means that where you're dealing with the hydrogen ions or the hydronium in water, right? The pH is only dealing with what is equal to the negative log of the hydrogen ion concentration. That's what we're talking about with the pH level. So, I mean, you're going on about all this stuff on the side that, I don't even really know what to say to, because it's like, If you didn't,
Okay, I did misspeak. Sorry, I'm just looking at different things here to see what it would. You see, because here's the thing, Ronnie. I don't take what Fiona says and take it as gospel. I don't take what Steve says and take it as gospel. I look at things for myself because I know this is going to seem very intricate for you, but I tend to look at things for myself because I know people can make mistakes, people can make errors, people can misspeak, people can use erroneous information. So do you know what I do? I look at things for myself, and none of it agrees with you.
okay,
I'm looking at this thing. Right, I'm looking at biochemistry now on a site called biology.stackexchange.com, and it explains to me that DNA, while being an acid, doesn't act like other acids.
do you know why it doesn't act as other acids? Did you hear anything that I just said to you right now?
Because
it doesn't act as other acids. It doesn't act as other acids as most other acids because it's a weak acid. That's the point that I'm trying to tell you. Weak acids. Just stop it for a second because you're all over the place. This is insane. It's acting as a weak acid, and weak acids are going to dissipate into the water differently than other acids. This has to do with the equilibrium state and how long they're going to stay in water. This is the point here. It's going to dissipate into the water differently than other acids are. DNA is an acid. It's called deoxyribonucleic acid for a specific reason.
Yeah, it is. Yeah, it's
an acid. It's an acid. That's the entire point.
I just said I was mistaken.
And if you're not understanding, if you're not understanding that DNA can act as both a water and a base, if you're not understanding that, what that even means, that's the entire point why it's water soluble, because the pH on the sugar phosphate backbone, that partial negative charge on that sugar phosphate backbone, and what that pH level actually has to do with in water. I don't even know really how to approach you on this particular topic, because I'm just sorry, but this is an insane display of ignorance by you right now.
No. I just apologize for misspeaking because I was looking at the wrong goddamn webpage. I'm looking at a correct one because I was looking at one that was done by. It was a forum base, which I do apologize for basing an opinion on a forum base.
Okay, so what do you apologize for specifically? Are you tracking?
For saying DNA is an acid, it is because it's declared nucleic acid, right? But it's a phosphoric acid. Now the thing is that
no. But that's not what's important right now. You said that water is not both an acid and a base. First of all, what did you think? Why do you think that it's neutral?
Because it is neutral.
What makes it neutral, though? You're being very, very vague in what you're saying right now.
Okay. The pH level of water is between 5 foot. Let's look at the pH level of water. It's 7 of pure water. It's between 6.5 and 8.5. So it could be all this up. It depends what kind of water you're talking about.
No, so water acts as both a water and a base because it both donates hydrogen and it both accepts it. That's the reason why. Right.
So at 25C, the pH level of water is very close to 7. Acids, as I said, they have a 7, are less than 7. While bases have a.
Did you hear what I just said to you? Did you just hear what I said to you?
Go ahead.
Acids donate, right? They donate, and what do bases do?
The bases do. What do you mean?
What do bases do?
It says it has. It's this thing that it's based upon. Surely,
it's based upon. Water acts as a base because it accepts. Right? It is accepting what? What is it accepting?
Other chemical compounds. That's
other chemical compounds. Water acts as it donates and it accepts hydrogens, right?
Yes.
Acids. You know what an acid does, right? It's donating it's donating, right?
Yes.
And water or bases, they accept, right? So you understand why, because water can both accept and donate a hydrogen, why it can act as both a base and a water, or a base and a water base and an acid.
Yeah, that's what I was just saying a minute ago before you interrupted me.
But you didn't say that a minute ago. You came out of nowhere when we were talking about when we were talking about
Acids
when we were talking about DNA, when we were talking about the Ka value of DNA, you came out of the woodwork out of nowhere and made some assertion that no, it's not. DNA is not, or water is not both an acid and a base. You started going on about its pH level.
I said it's neutral. It's the pH level is neutral.
You did change that afterwards, but I understand. I want to know if you're actually understanding what you're reading from. That's the point here, because yeah, it's neutral. No. But why is it neutral?
Why is it neutral? Because its spectrum falls into the neutral pH level.
But it donates. The point being, the main point is that it donates both. It donates and both accepts hydrogens. Man, that's the point here.
But everything but what is part of it has hydrogen as part of its genetic?
No. Not everything acts that way. Not everything acts that way. Not everything donates and accepts it. If it donates, if it donates or if it accepts, that depends differently. If it donates an acid, if it donates a hydrogen, that's going to make it an acid. If it accepts, it's going to be some sort of base.
Right, but the point I'm trying to get across is that there are different definitions of acid and base.
It doesn't matter if there's different. Look, there's no. First of all, there's no different definition of acid and base. That's not true at all. And if you think that there's a different definition of acid and base, that or some sort of other definition refers to a base donating and accepting an electron, that's not water or some crap like that, I mean, you're going to have to actually show that here, because there is no textbook that's going to be agreeing with you on that. None.
Okay. I'm on this thing, as I said, chemistry.about.com, acid bases. Acid and bases. There are several different methods of defining acid and bases. While these definitions do not contradict each other, they do vary in how inclusive they are. The common definitions of acids and bases are aldehyde acid and bases, the Brockley acid and bases, and the Lewis acid and bases. And I'll post that down below so you can look at it yourself. This is from a PhD in chemistry.
Okay, so do you know anything that he just said right now? Because you realize that nothing that he just said disagreed with me, right?
He. She.
It doesn't matter, he or she, who cares? What you just said did not disagree with anything that I said at all, right?
Well, you just said there's one definition, and I said there's several.
I don't care about the definitions. You see, this always comes, it's just like this DNA, this dissolving and degrading thing. I don't care about the definition. I care about the freaking science. That's what I'm concerned with. Okay, that's what's important right here. So she can define it as being something differently, but she's not going to disagree with the fact that the acid and a base for specific reasons. The pH, of course, I explained that to you just now, what qualifies as something being either an acid or a base, to help you understand why DNA is an acid. When we're looking at the pH value. I think now you do, because afterwards you went and Googled.
No, because I was looking
I then went from there. I tried to talk about the K. Okay, if you know why it's a weak acid, right? Why not a strong acid? Explain that to me.
Pardon? Was it? Sorry, you cut out. Sorry, I do apologize. You cut out for a minute there.
It is a weak acid or a strong acid? If you're looking at an acid,
okay, it says it here. You see, because you see, you keep asking questions that are on here. The stronger electrolytes are completely dissociated into ions of water. The acid or base molecule do not exist in a aqueous solution. Only ions, weak electrolytes are completely dissociated. It goes into strong acids, completely dissociated with water, compared to H plus and ionized. And there are 6 strong acids. The others are.
Do you understand anything that you're reading right now? Do you understand anything that you're reading right now?
Do I understand it? Yeah, I understand some of it.
Okay, well, what is it referring to?
It is the strength of bases and strength of acids, isn't it not?
Okay, Obviously, it's saying that. And obviously, it's saying that. Obviously, it's saying that. But do you understand what it's referring to? I'm asking you to explain it without looking at some article. I'm asking you to explain it to me.
What? So looking at evidence is wrong, is it?
You're not giving me any evidence for anything. You're getting off topic with all sorts of information that you should have learned in high school.
Wow, dude. I mean, because you see, unlike you, I try and look up things to
I'm not
case for something.
Look, you're not doing that though. We're trying to help you. We're trying to help you understand right now why it is that you're not understanding this topic. What I was trying to get at with you right now is the Ka value, right? If it's favoring the reactant, that is what's going to determine if it's a weak acid. But if it favors the product, that is going to be what makes it a strong acid, right? If it's favoring the product.
That's what it says here.
You should understand what it's saying when it's speaking there. That's the point here. You're not understanding it. You're reading from something. Your quick verses all over the place, and you're reading from different places, but you're not realizing how it's falling in line with what I'm saying. That's what I'm trying to say.
I'm reading from chemistry.com, chemistry.about.com, which people can go research themselves and see that I'm reading exactly what's on the page.
That's not the point. The point is that what you're reading is falling in line with what I'm saying, but you're using it.
No, it isn't.
It's exactly
it doesn't say that DNA is a weak acid at all.
Okay.
Or that it has a weak base or anything. It says ammonia has a weak base.
Okay. DNA is not a weak base. DNA is a weak acid. Do you understand?
That either.
Okay. You're going to have to stop for a second. It's a weak acid. You're not understanding the Ka value. You're not understanding why it's saying what it's saying. That's the reason why you're not understanding what it is that is falling in line with what I'm talking about. That's the problem here. So if you're using this in some sort of way to try to disagree with me or to try to make your point that DNA is not degrading or being water soluble, you're failing because all you're doing is you're getting off topic with some sort of information out there, general information that is not even related to the topic. You're just saying, you're repeating the same thing that I'm saying to you now, right? And you're trying to use it in a way to try to discredit me, but it's only saying the same thing that I'm saying. And that's the frustrating part about this. You've got to get into some sort of point, and you've got to show your position here.
Okay, my position is DNA does not degrade in water, at least for 100. It does not start for at least 100 million years.
Okay.
Right.
Now, I've heard the assertion, but I've heard the assertion already, but I'm looking for some scientific evidence behind the assertion.
Right. And the reason for that, because the base structure will be present in water if it dissolves. Again, you would need, even do the test for yourself. Get some of your blood, put it into some water, keep it at room temperature. Just make sure it's kept at room temperature. Keep on looking into it for a month.
The point isn't. What are you talking about? What are you talking about? Do you remember what I just told you in the other hangout? Who gives a crap about room temperature? No one's talking about room temperature here. That's a straw man fallacy where you're attacking another man's argument rather than the argument being presented. Okay. The only person. Stop it for a second, Gary. I'm trying to speak here. The only person that is talking about that is you and Fiona. Nobody cares about that. It was already acknowledged months and months and months ago that from negative 30 degrees Celsius to 70 degrees Celsius, DNA will be fine in water for a certain amount of period of time, right? Nobody disagrees with that. But once you start moving on to the heat that's involved in the early Earth, that can range anywhere between a couple hundred degrees Fahrenheit to 2,000 degrees Fahrenheit, that increases the amount of how quickly the DNA will start to break apart to come apart in water. So there's no problem at all with whether or not DNA can stay in water at room temperature. They do warn you in some of these solutions to actually store it at a certain temperature because it can degrade, especially if you're not doing it with a buffering agent and you're dealing with nuclease water or nuclease-free water. But that's not the problem at all. I don't know how you're not understanding that. Like, that's not the problem at all. Okay. Why are you going on about that?
Okay, so I'm going to ask you a question now, right? What was the temperature of the early Earth? And what's the source for that you have?
The temperature in the early Earth was anywhere between 300 to 2,000 degrees Fahrenheit.
Where did you get that from?
I get that from various different scientific sources. I got that from I've gotten it from Wikipedia before, and I don't even actually like Wikipedia. Well, let me Google it for you really quick, because this is actually an older topic. This one talks about how the early Earth was 1,800 degrees Celsius.
What time period are we talking about?
I got to look through it. Hold on. Yeah, you can look through it too. I'll give you the link on the side.
Okay, I'll look see through it. Okay. SolarSystemCentral.com. Okay. Right, so it talks about volcanoes everywhere, the very early Earth. 4.5 billion years ago. We're talking about that. The magma oceans and stuff like that. We're talking about that.
Okay, and here's this link here. Give me one moment.
100 degrees. Seems to believe that the formation hydroenvironment force. Yeah, the atmosphere. Sorry, I do apologize, everybody. I'm just reading through this. First oxygenation event, 2.3 billion years ago.
And 1,800 degrees, that's like well over 1,800 degrees Celsius. That's well over 2,000 degrees Fahrenheit. That's well over 2,000 degrees Fahrenheit already. If we look at that article, so you can see the problem. I mean, it's freaking impossible. It's not going to last 33 million years. The other bonds, even in their article, were going to freaking fall apart much quicker than that. So
yeah,
I'd be willing to wager that this is going to fall apart much quicker than that.
You want to read the actual article that you get it from.
Right. Do you know, this is kind of funny. Do you know what it's referring to in this other link that we were getting at? I'm looking at the other link that you gave me, too. It says there are several methods of defining acids and bases. While these definitions don't contradict each other, they do vary in how exclusive they are. The most common definitions of acids and bases are Arrhenians, acids and bases. It says the Lewis and acid bases. And then it goes on to talk about below. The bases produce the OH negative ions in aqueous solutions. Water required, so only allows for aqueous solutions. Only proteic acids are allowed, required to produce hydrogen ions. Only hydroxide bases are allowed. Do you even know what this thing was talking about when you sent it to me?
It's talking about the acid bases of different acids. That's what it's talking about. The definition of different acids.
No. They're talking about acid bases and the methods of how they're defined, basically.
Yes. That's the reason.
What was the point in you sending this to me?
Because you said that there was one definition, and I said there were several, which I was correct about.
No, nobody said at all that there was one definition. What are you going on about that there was one definition?
Anyway, I want to discuss this. I want to discuss this page that you just sent me. I'm
trying to understand.
No. Don't change the subjects. Right. The thing is that you said it was helium hot about 1,800 degrees Celsius. The temperature is the thin hydraulic atmosphere, and the surface of the Earth was approximately the same. There's no molten core. The core was probably as warm as the surface, because it consisted of magmatic ocean. Where is the water in that equation?
The water in that equation. We're not talking about the water in that equation. We're not talking about the water in that equation. We're talking about the ideas of abiogenesis. And if this is the early Earth environment being that freaking hot, how do you think it's going to affect it? How do you think it's going to affect that? You got to follow the discussion, dude. You can't keep getting off topic with this. You got to pay attention to what we're saying here. We're talking about the temperature right now and the water, the state of the water. People believe that are supporting abiogenesis that it was either some sort of free-floating nucleotides of some kind, some sort of ocean vents a long, long time ago, or some sort of idea with some sort of ocean form, a foam. You look at the Sostek experiments, for example, with some sort of self-replicating RNA and some sort of free-floating ocean or ocean foam, right? So the temperature of the water, the temperature of the environment at that time is what we're looking at right now, 1800 degrees Celsius, which is well over room temperature, I don't even know specifically what that comes out to in Fahrenheit, but it's very, very, very hot,
but read
right?
what he actually says.
So the point being is that if the temperature is that hot, please try to follow me with what I'm going to say right now.
Okay.
If the temperature in the early Earth is that hot, and we're talking about life coming about in some sort of liquid environment like water, right? You can see then how this ends up being very negative with the claims that were actually made by Fiona, to where the bonds could last 33 million years at room temperature, because room temperature is going out the window because it's well over room temperature.
Right, but the point is that you're misunderstanding what this article is actually saying. If you actually read it, it said that there was no water. It said that there was oceans of magma, which is looking right.
Okay, and as it began,
which just like the rest of the planet.
You know what
and then they said that the water arrived later.
Do you know what the greenhouse gases were? We're talking about the greenhouse gases as it began to cool down, Fahrenheit to 2,000 degrees Fahrenheit, right?
Mm-hmm.
So we're talking about the space of time after the Earth cooled down to what the time frame was to when life possibly began, right? From the Precambrian era, this is basically when all of this happened. 88% of the geological time scale, long time ago, over 540, 600, 700 million years ago, was when this possibly happened, right? So we're looking at a specific period of time when we're speculating or life possibly might have happened. That temperature, that's obviously not room temperature, isn't it?
1,800, no, it's not room temperature. But if
I'm talking about 2,000 degrees Fahrenheit, that's what I'm referring to. That's not room temperature, is it?
No, it is not, no. But if you actually read the piece that you're citing to me, it says that by 4.4 billion years ago, scientists believe that the Earth had cooled below the boiling point of water, 100 degrees Celsius, and some water was present. So how could water exist 4.5 years ago when the weather was 1,800 when there was no water present at the time?
Well, we're not talking about like at the beginning of the Earth. We're not talking about that particular idea. Nobody's referring to that. Obviously, if it was too hot, and we disagree with that anyways to begin with, from a creationist standpoint. But nobody's referring to that. We're talking about the period of time. I mean, I feel like you're not following the topic at all. We're talking about the period of time of abiogenesis. We're talking about the period of time of abiogenesis. We're not talking about what happened directly when the Earth actually first, got hot and the magma was there and everything else.
When did scientists say that abiogenesis started?
I'm not specifically sure when the period was. That's irrelevant. Why are you asking that question?
No.
I would say I'm sorry, I shouldn't have said that. That's not irrelevant because the time frame is actually really important right here. So give me one moment. I'll try to find that out for you.
Okay.
I'd argue that they don't know. I mean, nobody really knows when it actually happened. There's very little that's actually known about abiogenesis. But I know some mathematicians like John Lennox, when he looks at the time period that's speculated and the probability of it actually happening in a very short period of time, it's extremely, extremely unlikely. But as I'm looking for this, I would like for you to actually, sort of make a point, because we're getting onto this issue of what I see as the problem with abiogenesis because of the temperature at that time. But we're not seeing any reason that you're offering here that degrade and dissolve are not the same thing.
Right, here's one of the different things. Dissolve means that the chemical structure of the item still is intact, but it's in a different form. Whereas degrade means that the structure has begun to fall apart and has been replaced in some way. That's what that's what it means.
But that's clearly not entirely what the case is, because I just described to you, and I showed multiple different definitions and a chemistry site that said exactly what I just said to you. Let's go back and look up specifically what it was that I said. I'm going to screen share this one more time so that hopefully you get this, okay?
Okay.
Okay, so dissolve in water means what? It means that DNA dissolving in water. Why? Because of DNA in water, they can easily dissolve because of that partial negative charge of the sugar phosphate backbone. Dissolve means to break down, right? That's what it's synonymous with. It means to break down, as it says right here, so everybody can check it out. Degrade means what? To break down or to deteriorate chemically. That's what specifically it means. To degrade, let me pull up that definition of degrade really quick so that we can check it out. Degrade means what? To break down or deteriorate chemically, all right? So if A is the same as B and B is the same as C, then C is the same as A. You don't want to agree with that. We go back all the way over here to the actual chemistry website. It says right here, dissolving means that a solute breaks up into the solvent, and the covalent solid glucose breaks up into the molecules. So I'm trying to highlight so you guys can see it.
Okay.
Dissolving means that the solute breaks up in the solvent. The covalent solid glucose breaks up in the molecules into the water and makes a solution. I'm trying to show you these these definitions from different sources, multiple different definitions from different sources. I'm not trying to be condescending to you. I'm really not. But as I'm hearing you try to explain the pH value, trying to understand what water actually is, I'm not really very confident that you get this topic on an actual chemistry level, because right there, what you don't, because when I'm talking to you about what water is and why it's important, I mean, not understanding that it acts as both a water and a base, that's like fundamental there. I mean, that's one of the main points there. You're going to have to understand what happens when something enters into a solution.
I do understand.
To me, that's a big red flag. That's a big red flag, man.
I do understand what happens into what it enters a solution. You see, the thing is that, like, again, there are people out there who've actually done these tests, and we can go to their work and see if degrade and dissolve mean the same thing in biochemistry. They don't. You see,
I know that. I know that. I've done experiments. I've done experiments myself. I haven't really messed with any DNA, but I've done experiments myself, and I'm telling you, you don't know what the hell you're talking about. You don't. I'm sorry.
By the way, Fiona is in the chat. You said that Fiona wouldn't debate with you.
Yes, I said that Fiona did not want to actually have a debate with me.
I think that's not quite true, because I think that she has said that she would have discussion about you about this topic.
No, that's not true. And actually, I can go screen share something if she's going to backtrack that and be dishonest. I can screen share the actual discussion that happened on Antonio's channel so that people can see it. She refused to have a discussion. Jade accepted to have a discussion. And she ended up saying that she didn't want to have the discussion because she didn't know enough about abiogenesis to talk about it. But Fiona backed out. She didn't want to have a discussion with me. If she's changing her mind now, well, that's great. That's all well and good.
No, I'm not saying she's changed her mind now. I mean, she may hold the same position. I'm just saying, I've heard her say that she would have discussion about this topic with you.
Right.
But I don't know.
I want to investigate. I want to investigate this because this is very interesting to me. And I'm not saying this to be condescending to you at all. Don't take offense to this, but I'm having a lot of different people talk about this particular issue of DNA and water, and I'm hearing a lot of people who are going along with the norm of the secular community, and they're just pretty much going along with what Fiona says and some of the other dissenters who disagree with me say. But it doesn't appear that there's actually a good grasp on this actual topic. Do you know what a hydronium is? I want to ask you. I want to ask you a question.
Can I just throw a caveat out there? Right. I admit, and I admitted at the beginning of this conversation, that I am not a science graduate. My academic career is in languages, specifically in English. Well, science is
That's
an
good.
interesting.
That's fine. That's fine. Then why not be humble? Then why not be humble about it? No, you're not though. But look no, you're not. You're not doing that at all. As you're speaking to me, you're not being humble at all, man. Your approach to this is, oh, you're wrong, True. And as I'm asking you to naturally, hold on, will you stop interrupting me while I'm talking? Because I'm going to start muting if you keep interrupting me, man. As I'm speaking to you, and I'm trying to ask you about, the DNA in water, why it's even water soluble, what makes it a weak acid, what separates that from this weak acid from strong acids? How do you determine that? What water is? How you didn't realize it acts as both a water and a base. The pH level, and then so many other things we talked about. Now you've mixed up so many different things, and as I'm talking to you, you're actually going to websites trying to discredit what I'm saying by giving me websites that are saying almost the exact same thing that I'm explaining to you. So I'm not trying to be rude to this, but it's coming off as if you're not understanding what I'm even telling you. And this isn't being condescending to you. It really, 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 really is not. But I think we need to investigate that, because I think that's a serious, serious problem here. You can't sit over here and say, well, you're being humble, and then, make some sort of quick disclaimer that, look, I'm not a scientist and I teach, my major in language or whatever you said, and then use it as an opportunity to just try to excuse your ignorance, and that you don't really even have a basis to be disagreeing with me to begin with.
Yes, I do.
I mean, that's all right. Well, let me ask you a question. Do you know what a hydronium is?
Do I know it? No.
Okay, it's H3O plus, right?
Okay, but there's nothing difference between you and me. If I don't know something, I'll say no.
Oh, if I don't know something, I'll say no too. But if I do, I'm not going to say that. That's the difference.
Okay, so then DNA doesn't degrade in water because people who are scientists have said so. And I'm not just going about people out here. I'm going to people in actual scientific papers. Again,
nobody says that. Show me a scientific paper from somebody outside of this community that uses that phrase, DNA does not degrade in water. Show me that.
I posted it with DNA storage and quality. I posted it before.
That's not what it's referring to. When you gave me that, that's not what it's referring to. If you're referring to some other link, you got a couple of links on the side. Point out whatever other link you're talking about.
No, I'm talking about the DNA storage and quality. That's what I was talking about, because it talks about how DNA is stored in lamps and how they store it in water.
Right. It says room temperature on a dry solid matrix. Again, you're not understanding. I'm reading it right now. Room temperature at a dry and solid matrix. Negative 20 degrees Celsius, 80 degrees Celsius, and 196 degrees Celsius. What is it that we were saying to you? Or is that a negative 196 degrees Celsius?
Yes, it goes into the different states. And
what did we say about temperature? What did we say about temperature?
You said it was 1,800 degrees, and I'm saying that when life began, it wasn't 1,800 degrees.
That's not what I said. 1,800 degrees. That was actually 1,800 degrees Celsius, which is well over 2,000 degrees Fahrenheit. That's well over 2,000 degrees Fahrenheit. But that's not what I said. That you can store it at a certain temperature, right? You can store it at a certain temperature, at either freezing temperature or maybe possibly around I even grant you slightly even more above room temperature. I'll grant you that, right? But as you increase the temperature, and I feel like a broken record, as you increase the temperature, the heat of that water, what is going to happen? the bonds are going to start breaking apart at a much more rapid rate, right?
Yes,
So
I agree. I agree with
giving
that. But here's where you're wrong. But here's where you're wrong. Right. It wasn't 1,800 degrees Celsius when life began, though, was it? If you actually read the book, the thing that you linked to me, it says that it had oceans of molten lava. The thing is,
now we're off topic.
Excuse me.
Again, before we get on topic, before we get up, because we're going to get off topic and we're going to move right back to the original, to that problem again. What are we talking about now? Degrading in water. You showed me that degrading in water is solubility and something going into solution and degrading are not the same thing. That's what the original claim was, right? So that's the claim that we have to actually back up right now. I backed up my claim with different sources, with different definitions. So I would like for you to back up your claim that that is not the same thing.
Okay. So let's look into what dissolve means chemically. Let's look at it means chemistry. Okay. Let's have a look at that. When I say it goes into the dissolution of ions, so it talks about definition from the chemistry topic. Here we go. If a solid dissolves, or if you dissolve it, it mixes with a liquid and becomes part of it. That's what dissolve means, according to, is it Longman? Longman, which is fairly decent. And it goes into how it can be used in terms. Now look, let's put the same one in degrade. Let's see if it means the same thing, shall we? Chemistry. There we go. Let's look. Degrade. Sorry, it goes into a lot of things about something that if a substance, chemical, etc., degrades, or if something degrades, it changes to a simpler form. How does something absorb into it, make it a simpler form?
I'm sorry, man. I was waiting for you to actually make a point right there, and you didn't make a point.
Okay. I just gave you the definitions of
when something is breaking down. When something's breaking down, for example, with let me ask you, what is sodium chloride? You know what they are?
Yes, I know what sodium chloride is.
What is it? What type of elements are they?
It's an acid. It's a salt. It's salt.
Okay, well, sodium chloride, what is it? It's a non-metal and a metal, right?
Yep.
What's happening within the water?
It dissolves.
It dissolves. But what happens when it dissolves?
It becomes part of it. As I just gave the definition of chemical.
Water molecules pull apart the sodium chloride from among each other. That's what it's doing. It's breaking it apart. What happens with covalent compounds in water?
It mixes with the liquid. It becomes part of it. I think that's
okay. I know you're trying to hold by your position, but you didn't understand that one definition that I just read to you, actually. And I guess I'm going to have to screen share this again so that people can see it, because look, you're completely unprepared for this topic, and I think you need to be a little bit more humble here. Yeah, you're right. Wow. I mean, I don't know why you guys don't go and do research before you guys try to disagree with
I have researched
science.
It.
Before you guys try to disagree with science. Apparently not, because you're not even understanding anything you're saying, dude. Now I'm going to screen share this right here again. I'm going to screen share this again. I'm going to start muting you if you keep interrupting me. Dissolve, again, this is what he was basically reading from. He was talking about this, the definition of dissolve. With reference to a solid, it becomes or cause to become incorporated into a liquid as to form a solution. What are the synonyms for this? What does synonymous even mean? I'd love to know if you even know that. To break down. To degrade, what happens when something breaks down? It deteriorates or comes apart chemically. That's basically what it means. That's what it refers to. I mean, it doesn't matter. It does mean that. I'm showing it to you right now. I mean, is this really just going to turn into a definitional game? Break down or deteriorate chemically. This is what degrade means right here. I'm looking at the screen right now. I mean, I'm screen sharing it for you.
No, that's what degrade means. That's not what dissolve means.
Okay, well, here's what I just told you what dissolve means. Dissolve means what? It's synonymous with breaking down, right? Here's the chemical website for you again. Here's the chemical website for you again, okay? Let me zoom in so that maybe you're blind. Maybe you can't see it, okay? Dissolving means when a solute breaks up the solvent and the covalent solid glucose breaks up and the molecules enter the water to make a solution, to make the solution, okay? Go back over here, dissolve, what does it mean? It's synonymous with breaking down, right? Degrade is, what does it mean? To break down and to deteriorate chemically. This is really hard to grasp, man. And I really don't think that there's really any more for us to say at this point, man.
No, you're
denying science, man. You're denying science, and you're going against what the secular people are saying. That's all you've got.
No, I'm not. No, I'm not. Because you keep on saying that breakdown and dissolve means the same thing as to break down chemically.
Okay, maybe I should screen share it again for you. Maybe I should screen share it again for you. Okay, if A is the same thing as B, and C is the same thing as, or B is the same thing as C, you have no reason to tell me that C is not the same thing as A. If all the definitions are synonymous with each other, if all of them describe the same thing, the chemical websites even describe it the same way, then it's the same freaking thing. The only thing you can sit over here and say is that when covalent and ionic compounds break apart or come apart, they're coming apart differently than an hydrolysis reaction. That's what you can only say. Hydrolysis reactions, they break down more specifically and in more detail. That's the point here. There is no problem with any of this stuff being defined as degrading or coming apart or breaking apart. There's no problem with that at all. The problem that you have is what is being said in this ignorant community that we're a part of that is in denial of the actual scientific evidence. And I've sat here for a good proportion of time speaking with you, and I've heard nothing but how you feel about what's being talked about. There's been no science actually offered to defend your position.
Okay, so you want me to?
I'm gonna end it here. I'm gonna end it here. Quite honestly, I'm very disappointed in this discussion. I'm sorry. I'm not. I've allowed this to continue for way too long, and I'm sorry, but I'm way too disinterested to keep this discussion going, man. I've sat back listening to you for a good long time talking about this particular issue, and this isn't going anywhere. I mean, I'm amazed that you can sit over here and talk so boldly about this topic, not knowing what water is. I mean, why it acts as both a base and an acid. How can somebody sit over here? The goal is to try to sit over here and talk about what they think they know about chemistry, not even knowing that. I mean, it's just beyond me. And quite honestly, I'm just in awe of what I've heard here. But for the people that are listening, hopefully you really dwell on what actually just happened here tonight.